Let's find the extrema and figure out where the function is increasing or decreasing. To do so, we're going to start with the derivative. The derivative of sine is cosine. The derivative of cosine is a negative sign. However, there's also a negative out front. So what we've got is a double negative. And that derivative of the function is going to be cosine x plus sine x. Okay. Well, we're going to set this equal to 0 so that we can solve for critical numbers. When we do sine x plus cosine x, set it equal to 0, and we're wondering what values of x will make this true, or what are the angles. Of course, we're pretty clueless. Well, we're still clueless. Doesn't matter if you put the sine first or the cosine first. We're wanting to know, really, where you have opposite sine and cosine values, where you have opposite y and x values from the unit circle. Well, there's only one type of angle where x and y, sine and cosine, are either the same or opposite, and that would be a reference angle that is a quarter pi or 45 degrees. Think about it. In quadrant 1, both x and y are positive. In quadrant 2, x is negative, y is positive. Quadrant 3, both x and y are negative, and in quadrant 4, x is positive while y is negative. So you do have opposites in two places, not quadrant 1 and not quadrant 3. What we need is a 45-degree reference angle in quadrant 2. That would be 3/4 pi. It is a quarter pi less than 1 whole pi. We also need a 45-degree or quarter pi reference angle in quadrant 4. That would be a quarter pi less than 2 whole pi, which is 7/4 pi. These are our critical numbers, and I had to have knowledge about the unit circle to figure out where sine and cosine, where y and x were going to be opposites. Well, now that we know that, we're going to use those numbers, 3/4 pi and 7/4 pi, to test a value by plugging a value from each region into the derivative. Something less than 3/4 pi. Well, there are a lot of things less than 3/4 pi. For no real reason, I'm going to test a 1/2 pi. And then I'm going to test something in the middle between 3/4 pi and 7/4 pi. Lots of choices, like 5/6 pi, 1 whole pi, 4/3 pi. But I'm just going to choose to test 3/2 pi by plugging that into the derivative. And something bigger than 7/4 pi, well, something really more than 7/4 but less than 2 whole. And I just decided to use 6, less than 2 pi. Less than 2 times 3.14. Well, that's less than 6.28. Now 7/4 pi in decimal form is about 5.49 and many more. Something bigger would be 6. Okay, so let's plug into that derivative. And we found the derivative to be cosine x plus sine x, or the other way around. So if we plug a 1/2 pi in, that's going to be the cosine of 1/2 pi, the x value, plus the sine of 1/2 pi, the y value. That gives us 0 plus 1. The point is that that's a positive number. Because it's a positive, we know that our function is increasing there. Let's check out the other side. Let's check out the middle. We'll plug a value in from the middle. And we said that we were going to plug in 3/2 pi. If we do, we've got the cosine or x value at 3/2 pi. Add to that the sine or the y value at 3/2 pi. That's 0 and a -1, which is -1. The point is that it's negative, so the function is decreasing. We'll check out the other end. We'll check out the other side by plugging 6 into the derivative. So we're going to evaluate that derivative at 6. So we got the cosine of 6 plus the sine of 6. When I did this using a calculator in radian mode, I got something like about 0.96, and we were adding to that, I don't know, something negative. I'm not really sure what, but in the end, what I got was 0.68. Let me check and see, just for fun, that the sine of 6 was about negative 0.28. And when we combine those, we get something positive. So we know that the function is increasing here. Well, we can write where the function is increasing and decreasing. And we know that if we go from increasing to decreasing, we've got a max by this x value. And that if we go from decreasing to increasing, we've got a min by that x value. Okay, so recall this is what the function looked like. One thing that I would forget is that we were only looking on the interval from 0 to 2 pi. This function is increasing between 0 and 3/4 pi. Then it is increasing again from 7/4 pi to 2 pi. It's decreasing from 3/4 pi to 7/4 pi. We do need to find our minimum and our maximum. We are expecting a max where x is 3/4 pi. So we plug that into that function. That's the sine of 3/4 pi. Take away the cosine of 3/4 pi. That does give us square root 2 over 2. Take away a negative square root 2 over 2. Whether you have this memorized, you understand it, or you calculate it, well, that's the square root of 2 over 2 plus another square root of 2 over 2, which is 2 square roots of 2 over 2. Psh! That's the same as the square root of 2. So we do have a maximum where 3/4 meets the square root of 2, relative maximum, maybe an absolute maximum. Anyway, we have a minimum. Let's find out what it is at 7/4 pi. So that was the sine of 7/4 pi, take away the cosine of 7/4 pi for our original function. That's a negative square root 2 over 2. Take away a positive square root 2 over 2. That's negative 2 of those square roots of 2. Psh! So this is our minimum. We got a minimum where 7/4 pi meets negative square root 2. We found our intervals that were increasing and decreasing, and we found our extrema, so we're done.